Welcome to Volume 7 of the Enterprise DevOps and Platform Engineering Study course. This 20-minute lesson covers production troubleshooting and interview guide, incident command, evidence-led diagnosis, recovery, and the goal is to build an interview-ready mental model, connect architecture with implementation, and show how a senior engineer diagnoses production failures. Take notes on the control flow, security boundary, failure modes, and validation commands in every section. The video is a guided overview of the complete handbook, so use the detailed document and labs for deeper practice after watching. Troubleshooting Principles and Incident. The module on troubleshooting principles establishes the following idea. Production troubleshooting. Lifecycle troubleshooting is a controlled reduction of unseen. The objective is to restore reliable service with the smallest justified risk while preserving enough evidence to explain and prevent the failure. Senior engineers begin with impact, scope, time, and recent change. They distinguish symptoms from causes and avoid random command execution. A disciplined process uses architecture, telemetry, and every destructive action should have an explicit expected result, rollback, and validate. Confirm whether the problem is real and use visible. Establish blast radius and time of onset. Preserve evidence before restarting or deleting. Prefer reversible tests and one variable at a time. Draw the architecture and identify the safest evidence for tests for troubleshooting principles. Explain mitigation, validation, root cause. The module on incident severity, command and communication establishes the following. Incident command and communication model. Incident response separates coordination from tech. The incident commander maintains priorities and safety. Operations leads drive mitigation. Communication leads publish accurate updates. The severity is based on customer and business impact, not technical excitement. Criteria should include availability, data integrity, security, regulatory. Updates should state impact, current action, risk, and next update time. Avoid unverified root cause claims during active response. Use one authoritative status channel. Protect responders from parallel exec. Draw the architecture and identify the safest evidence or tests for incident severity, command, and communication. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Severity, command, communicate. The module on hypothesis-driven diagnosis establishes the following. A hypothesis predicts an observable result. The best next test maximizes information while minimizing risk and time. Prioritize by likelihood, impact, and evidence. Recent changes are important but should not become confirmation bias. Architecture diagrams expose shared dependencies and compare healthy and unhealthy instances, paths, or time. Write the hypothesis before the test. State what result would confirm or reject it. Compare against a known good baseline. Stop when evidence contradicts the theory. Avoid multiple simultaneous configurations. Draw the architecture and identify the safest evidence or tests for hypothesis-driven diagnosis. Explain mitigation, validation, root cause. The module on safe mitigation, rollback, and validation establishes the following idea. Mitigation reduces impact. Resolution, a restart, failover, or rollback may restore service without identifying root cause. Every mitigation changes system state and may create secondary failure. Evaluate blast radius, data consistency, capacity, and role. Validation must use user-relevant SLAs and independent checks. A green deployment status alone is not sufficient. Prefer traffic shift, feature disable, or rollback over emergency code. Verify dependent capacity before. Observe after recovery for recurrent. Document temporary mitigations and draw the architecture and identify the safest evidence or tests for safe mitigation, rollback, and validation. Explain mitigation, validation, recall. The module on RCA and corrective actions establishes the following ideas. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correct. Hypotheses, vacation, rollback, and the module on runbooks, automation, and game days establishes the following ideas. Runbooks convert known operational knowledge into safe, testable. They should include trigger, impact, evidence, decisions, vacation. Automation should collect evidence and perform deterministic checks. Fully automated remediation is appropriate only when conditions and side effects are well understood. Game days validate people, process and technical control. They should have safety boundaries and learning objectives. Assign an owner and last tested date. Keep commands copy safe and context aware. Update after incidents and platform change. Draw the architecture and identify the safest evidence or test for runbooks, automation, and game days. Explain mitigation, validation. Recall the module on Linux and Systemd establishes the following ideas. Linux production triage. Full Linux triage starts with uptime, load, process state, failed units, logs, and resource. Load average includes runnable and uninterruptible tasks and must be interpreted with CPU count and I or O state. Systemd failures may result from dependency ordering, environment, permissions, limits, sockets, or repeated restart throttling. Kernel messages reveal OOM kills, file system errors, driver resets, and hardware warning. Use systemtool status plus journal U. Check process state D, Z in block tasks. Correlate boot and service timelines. Avoid reboot until evidence is collected. Draw the architecture and identify the safest evidence or test for Linux and Systemd. Explain mitigation, validation. Recall the module on CPU, memory, and performance establishes the following ideas. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on disk, file systems, LVM, and I or O establishes the following ideas. Disk incidents include byte exhaustion, inode exhaustion, latency, file system corruption, read-only remounts. Deleting an open file may not free space until the process closes it. A file system can be full while DF and do disagree. Storage mitigation must protect data integrity, force detach, file system repair, or LVM changes require explicit recovery. Inspect device and file system error. Draw the architecture and identify the safest evidence or test for disk, file systems, LVM, and I or O. Explain mitigation, validation. Recall the module on networking and firewalls establishes the following ideas. Layered network troubleshooting. Network troubleshooting follows the packet path from client resolution and route through firewall. Load balancer. Service and application list test from the same network namespace and identity as the failing workload. Host tests can bypass policy or DNS differences. Security groups, NACL, host firewalls, and Kubernetes policies are stateful or stateless in different ways. Confirm source, destination. Use packet capture at both ends. Check return path and MTU. Avoid assuming that ping proves application connect. Draw the architecture and identify the safest evidence or test for networking and firewalls. Explain mitigation, validation. Recall in an interview. Explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Networking, DNS and TLS diagnosis. The module on DNS and TLS establishes the following ideas. DNS resolution and failure domains. DNS failures can occur in search expansion, cache, recursive resolution, authoritative records, negative caching, policy. TLS failures involve hostname, certificate chain, expiry, protocol, cipher, trust store, client. Always test the exact hostname and SNI used by the application. Inspect TTL and negative responses. Draw the architecture and identify the safest evidence or test for DNS and TLS. Explain mitigation, validation. Recall the module on Docker and container establishes the following ideas. Exit codes and runtime errors must be preserved. Exit 137 often indicates SQL, including OOM. 120 Kubernetes nodes normally use CRI runtimes and should be diagnosed with critical and runtime logs rather than Docker commands. Check daemon and runtime separately. Inspect exact image digest and architect. Review mounts, capabilities, and capture previous logs before recreate. Draw the architecture and identify the safest evidence or test for Docker and container. Explain mitigation, validation. Recall from a senior engineering perspective. Connect these mechanisms to availability, security, scalability, change. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Docker, Git, Jenkins, and pipeline. The module on Git, GitHub, and webhooks establishes the following ideas. CI, CD pipeline troubleshooting flow. Webhook failures include wrong URL, TLS, secret validation, firewall, delivery retries, and event filters. Always inspect provider delivery logs and the receiving service access log before changing pipeline code. Confirm commit shy availability and branch. Verify credential scope and expire. Avoid force push recovery without coordination. Draw the architecture and identify the safest evidence or test for Git, GitHub, and webhooks. Explain mitigation, validation, root cause. The module on Jenkins establishes the following ideas. Jenkins controller and agent diagnostics. Jenkins troubleshooting spans reverse proxy, controller JVM, queue, executors, agents, plugins, credentials. A responsive login page does not prove the queue or agents are healthy. A thread dump and heap evidence are essential for controller hangs. Plugin incompatibility and unsafe upgrades are common causes of startup and pipeline failures. Check queue and executor saturation. Collect thread dump before restart. Inspect controller and agent logs. Validate plugin and core compatibility. Backup Jenkins HOME and test restore. Draw the architecture and identify the safest evidence or test for Jenkins. Explain mitigation, validation, root cause. The module on SonarQube and Tri-V establishes the following ideas. SonarQube and Tri-V troubleshooting chain. SonarQube analysis depends on scanner configuration, compute engine processing, database. The scanner upload succeeding does not guarantee the quality gate is computed. Security gates require governed exceptions and evidence linked to commit and image digest. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correct. Kubernetes workload and cluster. The module on Kubernetes control plane establishes the following ideas. Kubernetes cluster troubleshooting architecture. Control plane diagnosis begins with the API endpoint, API server readiness, etcd health, scheduler or controller status, certificates, and admission webhook. API latency can result from etcd disk latency, overloaded clients, admission timeouts, large objects, or controller storms. Managed Kubernetes still requires diagnosis of endpoint access, IAM, add-ons, nodes, and workload. Inspect etcd quorum and async latency. Review API request errors and deprecated clients. Preserve control plane logs where available. Draw the architecture and identify the safest evidence or test for Kubernetes control plane. Explain mitigation, validation, root cause. The module on Kubernetes workloads establishes the following ideas. Kubernetes pod debugging decision tree. Pod failure should be classified before diagnosis, pinning, image pull, configuration creation, crash loop, use events, status, current logs, and previous logs. Running does not mean ready or serving traffic. Controllers add rollout and ownership contact. Identify the new replica set or failing stateful set ordinal. Read the exact event message. Compare image ID, configures, inspect probes, and graceful shutdown. Rollback only after identifying compatibility. Draw the architecture and identify the safest evidence or test for Kubernetes workloads. Explain mitigation, validation, root cause. The module on Kubernetes scheduling and capacity establishes the following idea. Pending pods commonly result from resource requests, taints, affinity, topology, quotas, ports, PVC topology, or limits do not reserve capacity. Request drive schedule. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Helm, Argo CD, and GitOps failures. The module on Kubernetes storage and CSI establishes the following ideas. Kubernetes storage troubleshooting. Storage failures involve claim selection, storage class, CSI controller, cloud storage API, topology, attachment, node plugin. Pending PBC and multi-attach have different causes and risks. Forced attach can corrupt stateful workloads. Snapshots may be crash consistent but not application consistent. Inspect CSI controller and node logs. Check topology and access mode. Confirm application consistency. Protect data before manual finalize or change. Draw the architecture and identify the safest evidence or test for Kubernetes storage and CSI. Explain mitigation, validation. The module on Helm establishes the following ideas. Release state is stored in cluster secrets by default. A failed or pending operation can block later upgrades. Rollback restores rendered release state but may not reverse database or external changes. Use debug and server-side dry run. Check hook jobs and waits. Compare user and computed values. Draw the architecture and identify the safest evidence or test for Helm. Explain mitigation, validation. Recall the module on Argo CD and GitOps establishes the following ideas. Argo CD troubleshooting architecture. Argo CD failures involve Git access, repository rendering, cache, diff, application controller, destination cluster credential. Out of sync is a state, not necessarily an outage. Determine whether the difference is intended drift, defaulted fields, another controller, or failed rec. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. AWS monitoring and security incident. The module on AWS cloud troubleshooting establishes the following ideas. Identity errors require determining the actual principal, session policy, permission boundary, SCP and resource. Network diagnosis must consider route tables, security groups, stateless NACL, entity or VPC endpoints, DNS and load balancer health. Confirm account, role, and region. Use CloudTrail for change in authorization context. Check both forward and return network path. Inspect load balancer target reason code. Use Systems Manager instead of opening SSH where possible. Draw the architecture and identify the safest evidence or test for AWS cloud troubleshooting. Explain mitigation, validation. Recall the module on security incidents establishes the following idea. Security incident response. Security response prioritizes validation, containment, evidence. Availability actions must not destroy forensic evidence or allow continued identity containment is often safer and faster than deleting systems. Revoke sessions. Isolate network paths and preserve disk or process state according to the incident plan. Recovery requires credential rotation, trusted rebuild and monitoring. Use an incident-specific evidence store. Restrict access to sensitive evidence. Validate identity and supply chain controls before. Draw the architecture and identify the safest evidence or test for security incidents. Explain mitigation, validation. Recall the module on disaster recovery and major outages establishes the following ideas. Disaster recovery and service restoration. Disaster recovery executes a pre-agreed RPO and RTO strategy. Failover decisions must account for data loss, split brain, dependency capacity, DNS, and security. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Disaster recovery and senior interview method. The module on reference runbook library establishes the following ideas. The asset package contains reusable triage scripts, runbook and RCA templates. Scripts are intentionally read-oriented and should be reviewed before execution in production. Evidence preservation workflow. Confirm customer impact and assign incident commander and freeze risky parallel changes and record recent changes. Capture service SLO, error and saturation graphs. Identify common dependencies and fail. Collect events and logs before restart. Choose one reversible mitigation and validate through an external transaction. Schedule the next status update. The module on Game Day Labs and 6-week plan establishes the following ideas. Simulate a failed production release causing elevated errors. CrashLoopBackOff, stale Argo status, assign incident roles and publish time. Collect Linux, Kubernetes, Jenkins, Argo, and mitigate by rollback or traffic shift. Validate customer transaction and error bud. Produce RCA with at least 5 verified corrective actions. Present a 15-minute senior interview debrief, 10-minute hypothesis and evidence plan, 5-minute mitigation and risk discussion, 5-minute root cause and prevention. Feedback against the supplied scorecard. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent. You have completed the guided overview of Volume 7, Production Troubleshooting and Interview Guide. The next step is practical repetition. Recreate the architecture without looking at the handbook, implement the supplied labs, inject at least 3 failures, and document symptoms, evidence, root cause, mitigation, and prevention for interview preparation. Answer each scenario aloud using a structured sequence. Clarify impact. Establish scope. Check recent changes. Collect evidence. form and test hypotheses, mitigate safely. Senior level performance is demonstrated not by memorizing commands, but by making reliable decisions under uncertainty.